Happy Friday, everybody! Today, what we've got is a simple little lesson applying and using the Pythagorean theorem that you've learned for this week. One of the primary uses of the Pythagorean theorem is in measurement and as well as computing distance. And so next week, we will do more with measurement and with distance. But today, we just want to do some simple little application problems that will help you get ready for what I'm going to show you next week. Okay, so it says here to write an equation that can be used to answer the question, then solve round to the nearest tenth if necessary. Okay, so the first one says, how far apart are the spider and the fly? So if you notice here in this particular example that there is a right triangle that's drawn, and the distance between the spider and the fly is measured by the hypotenuse of the right triangle. So all I'm going to do is use what I know about right triangles and Pythagorean theorem to find the distance between the spider and the fly. All right, so since I'm looking for a hypotenuse there, I'm going to start with a squared plus b squared equals c squared. Now, like we've said, c is always the hypotenuse. It's always the longest side. And I know my two legs, so I'm going to let this one be a and this one be b. So that's going to be 2 squared plus 3 squared equals c squared. So 2 squared, that's 2 times 2 is 4, plus 3 squared, which is 3 times 3, and that's going to be 9. And all of that equals c squared. So then I add these two together. So 4 and 9 is 13. And that equals c squared. Now I'm going to find the square root of both sides. All right, so this is my inverse operation. So those cancel out. So c is going to equal, and let me come over here to my calculator, the square root of 13, which is 3.6. And we're rounding to the 10th. So I look next door. Is it 5 or more? It's a 0. It's less than 4, so we shut the door. Therefore, my answer is going to be 3.6. All right? So that would mean the distance between the spider and the fly is 3.6 feet. All right, so for the next one, it says, how long is the tabletop? So you're given the length of the diagonal across from corner to corner. Then you have the height, and you're looking for how long it is, or you have the width, and you're looking for how long it is. Okay, so this time you're looking for a leg, all right, because here I know my hypotenuse right here is 6, because that's my side across from the right angle. And then I have a leg of 3, and I'm trying to find the other leg. Okay, so what's different with this exercise today is the past few days, everything that I've given you has already had in there, find the leg or find the hypotenuse. Today you're going to have to determine which one you're looking for on your own. So I have a squared plus b squared equals c squared. So we'll let this one be a, and this one is going to be b. So I'm looking for a this time, so I'm going to have a squared plus 3 squared equals c squared, which my c squared this time would be 6 squared. Okay, so a squared plus 9 equals 36. Because 3 squared is 3 times 3, which is 9. 6 squared is 6 times 6, which is 36. So now I squared them, so I'm going to subtract 9 from both sides. And I have a squared equals 36 minus 9 is 25. Okay, now this is one of those perfect squares, so I should have memorized 5 times 5 is 25. Okay, but just in case you did not remember that, we can just go to our calculator, press the second function, x, and there's the answer of 5. So A equals 5. So that means the length of this tabletop, or how long it is going to equal 5. So you'll notice again, I have a side of 3, a side of 5, my hypotenuse is 6, my longest side is 6. So what you're going to be doing for the rest of these is you just have to look at the right triangle and determine for yourself which one it is, if it is a hypotenuse or a leg that you're solving for, and how you're going to use the Pythagorean theorem. So I will continue to work out the next two if you want to stay with me. If you want to move along on your own, you're free to move along on your own. Okay, so number 3 says, how high will the ladder reach? Okay, so if you notice here, I've got my right triangle that's made. I have a side of 4. I have another side I don't know, and then my hypotenuse is 16. So when I set up my Pythagorean theorem of a squared plus b squared equals c squared, okay, I have a and I have b. So what I'll do then is put in 4 for a, so that's going to be 4 squared plus my b value is what I'm looking for, and then my c value is 16. All right, so 4 times 4 is 16. So let me go to my calculator, and 16 x squared key is 256. So now I'm going to subtract 16 from both sides. So I get b squared equals 256 minus 16 is 240. So now I do the square root of both sides. So second function key, x squared. And I get 15.4919338. So I'm rounding to the 10th. So my 10th position is 4. So I look next door. Is it 5 or more? It is. So I add one more. So 15.5. So that means this side over here is going to be 15.5. All right, so for my last one, number 4, it says, how high is the ramp? So again, I have a right triangle. My hypotenuse, that side across from the right angle, I see is 17. So then I'm looking for the height, which is a leg, and then I know another leg, which is 15. So again, we'll begin with a squared plus b squared equals c squared. So this time we'll have a, and we'll let this one be b. Okay, so on my calculator then, I need to do 15 squared, so 15x squared is 225. And then 17 squared is 289. All right, so next thing I do is subtract 225 from both sides. All right, so then I get a squared equals 64. So then I take the square root of both sides, because that way I can isolate that a by itself. And the square root of 64 is, if you remember what 8 times 8 is, or what number multiplied by itself equals 64, the square root of 64 is 8. All right, so a equals 8. So that means that this side over here is 8 feet, so the ramp is 8 feet high. All right, so I think you could probably do the rest of them. Have a great weekend, and on Monday we will do some more problems using the Pythagorean theorem. It's been a good week. Have a good weekend. Goodbye.